Hello, YouTube! Today we're going to talk about sort of the basics of everything for Unit 1, and honestly, basically all of it. So a lot of what we're doing for this class is going to be what's called mechanics, which is pretty much just how stuff moves. Um, and we're going to start out by just saying, alright, we don't know why it's moving, we don't know how it's moving, we don't know what's making it move, but like, what happens when it moves? And then we'll get into sort of like how can we predict what it'll do beyond that, and those will be later units. So really, really important is that like everything from this unit, and especially I think today, is really, really just second nature for you. Like this is the equivalent of learning the alphabet. Um, if you don't know the stuff from today in such nuanced detail that like it's just fine, it's easy, and it's intuitive, like actively intuitive, the rest is going to be pretty rough. So yeah, let's dive in. In particular, we're going to start by just sort of saying, okay, well, can we describe the motion of an object using vocabulary? In particular, we've got velocity, displacement, and acceleration. The big one is understanding the differences between velocity and acceleration. And really being able to understand that, like, when you say that something's accelerating, what that looks like, what that feels like, and how that's different from saying that something's moving, and like which vocab words go with what. So, oh, I used to do this. Sorry, I haven't used this PowerPoint in a year. I've looked at it, but anyway. So position is where you are. So if you look at an object and you're like, oh, it's over there, that'll be its position. The only thing that's a little weird about it is that position always has to be relative to something else. So specifically when you're describing something's position, you're always going to have to give a reference point. Now, for most physics problems, that reference point is sort of implied, but you do get to pick where it is for the most part, especially when you're setting up your equations in your math. Because if I just tell you, oh yeah, I'm 3 feet from the door, you don't know where the door is. You don't know which door it is. There's actually multiple doors in the room I'm in, and one of them I'm 3 feet from, and one of them I'm about I don't know why I'm switching to metric, but one of them I'm about 4 meters from. So like 3 meters, nah, whatever. Point being that unless I make a more specific reference point, you knowing where I am isn't particularly helpful, because you wouldn't actually be able to get to that location. So, position tends to be fairly straightforward because it's just like it's here, this is where it's here compared to. Great. Distances tend to be a little more difficult because there's multiple ways to do it. An example I like to bring up is that, well, for example, I biked like 25 miles today, and I started at my house and I ended at my house. And my roommate spent the night over at one of their, I guess it was actually their parents' house, and then came back. And if you look at who moved more today or who went further today, they only traveled for about 5 minutes to get from there to here, and it's like 6 miles, 10 miles away. So they went 10 miles from location A to location B, but I started at location B, went 25 miles, and got back to location B. So there's this little bit of a weird thing where they went further away from where they started. I traveled more in total. And so this is really the difference between displacement versus the total distance traveled. So with total distance traveled, what that's referencing is how far someone actually moved. It includes any backtracking. Today, especially, we're going to be worrying about one dimension. Eventually, we'll get up to more dimensions, but for now, it's either just forward or backwards. So when you're describing total distance traveled, it's a little weird because the definition of the thing is just the words. It is anytime there was any change in position, all of that is being tracked. And it's everything along the way that matters. So what's important about this is that it's describing the process of what you actually did. Whereas displacement is just the distance and direction from the start point of where you began to the end point of where you wound up. And what's relevant and one of the big differences with this is that it doesn't actually tell you anything about what happened in the middle. Because it's possible that you overshot and then came back by an amount. It's possible that you went in a giant circle. It's possible that you just didn't ever move if you wound up at the same spot. But like, you don't know what happened except for the end results. What's weird about this versus total distance traveled is if I just tell you, oh yeah, I mean, I like drove for 120 miles, you don't know where I am at all. So you don't know what the end results were, but you do know what the process was like. Whereas if I tell you, oh yeah, 3 hours ago I was 10 miles south of here, you know where I started, you know where I ended, you know the end result and the beginning of that process, but you don't know anything about the middle. You have no idea how I got there. And that's really the big difference. Displacement is going to be telling you about the end and the start and the results of the thing. The total distance traveled is talking about the process. And that's going to be a theme for the next vocab set as well. So just, I guess, keep that in the back of your head. So big times where this could be different are anytime that someone turns around. So if you start in a location and you go forward and then you go backward by an amount, in the blue, we've got sort of highlighted a circuit of what would be your total distance traveled. So let's say this is 3, this is 2, your total distance traveled would be 5. Whereas your displacement would only be 1 because you wound up 1 to the right of where you started. So that would be a time when they would be different. But if you just have something where you've got a situation where one thing goes forward and that's it, for an amount of time, or one thing goes backwards for an amount of time and that's it, then the total distance traveled will be 3 and the displacement will be positive 3. There is a little bit of a difference between them always because the displacement has to include the direction, where the total distance traveled can't because it wasn't necessarily all in one direction. So the next way that we can talk about objects in motion is by describing what they're currently doing. So I can't easily demonstrate it, but I guess if I have my two hands, if I have one hand that's moving like this and then a second hand that's moving like this, there are two really big differences between what those two hands were doing. The first of which is that one of the hands was moving very, very quickly, which means that it goes, it has a large positional distance change. Like where it is changes very rapidly, meaning it takes a very short amount of time to change its location by a large amount. When you're talking about fast, when you're talking about slow, if you're describing what the object is doing, so if you're saying moving fast, moving slow, what you're describing is having a very rapid change in location or having a very gradual change in location. I try to avoid, I'm going to do it because just this is how English vernacular and how people talk. I'm going to try to avoid saying like it has a fast acceleration. While that's not necessarily incorrect, it does get a little misleading because that would tend to wind up leading you to think that it's moving very quickly. And I'm getting a little ahead of myself here, but what's new? That implies that it's moving very quickly. So more likely you should try to use like rapid or gradual for describing how long or short something is taking to happen. But what else? So typically the way we describe this is going to be with like a speed. So saying like I'm going 65 miles per hour, something like that. And that's really helpful, but there was actually another pretty big difference between the way my hands were moving. And that's that one of them was moving to the right, and that one was going slower, and one of them was moving to the left, and that one was going a lot faster. And so actually the direction that these things are moving in winds up being really relevant, especially if you're trying to figure out where stuff is going to end up. Knowing if it's going to the north or the south is going to completely determine or not completely determine, but completely change where it winds up. So, real quick, this is something that hopefully you have some level of familiarity with already, and you might not have spent a lot of time thinking about the implications because it feels so basic that, like, why would you have to? But if you have someone say they're going 20 miles per hour, that means that each hour they go 20 miles, right? Well, you can also either subdivide that or multiply that. In 2 hours, they'll go 40 miles. In half an hour, they'll go 10 miles. And all of that is going to sort of build together to describe, quite literally saying, this is the distance I go in this set amount of time. And both halves of that are incredibly important. You can't figure out how far someone goes with just the speed. You're going to also need the time. And if you're trying to figure out someone's speed, I can't just tell you, oh yeah, I went 40 miles. Because if I went 40 miles in 5 minutes, it's very different from if I went 40 miles over the course of 3 days. And so you really need both the distance and the time to ever think or talk about speed or movement. And we use meters per second in this class for the most part. 9 meters per second is the same speed as 20 miles per hour. For reference, it's times, I think, 1.1, 1.2-ish. Times 2.2, I believe, to convert from meters per second to miles per hour. But if you just think of meters per second and you multiply it by 2, that's roughly miles per hour. So next set of vocab is going to be speed versus velocity in the same way that total distance traveled describes like the process and displacement describes the end result. Kind of the same way speed describes just what it's doing in general, whereas velocity is describing where it's actually what it's doing in a more specific way that especially once we get to the averages for the next one, I think that'll become more relevant. So speed is the amount of distance your position is changing by each second. It doesn't necessarily mean that you're going to be 5 meters away from where you started at the end of that second. But if you say you're going 5 meters per second, that means that every second you will have to go a full 5 meters if it's constant. But that could be rapidly in a circle, that could be in a straight line, it could be in a zigzag. So it doesn't mean you're going to be 5 meters away from where you started at the end of that second. It just means that 5 meters of sort of ground will have gone under your feet. And that's also called your like rate of travel. And it's just how fast or slow you're going. What's important about the velocity is it's really close to that, but velocity is always in a straight line. And it's also including the direction of the travel, which is why it's always in a straight line. So if you say my velocity is 5 meters per second to the right, what that means is that every second you are going to be 5 meters more to the right of where you used to be. If you're describing a constant velocity, that will also mean that 5 meters pass under your feet each second. If you're describing an average velocity, that's not necessarily a guarantee. So really, really, really close to being the same thing. There are a couple times where the distinction is going to matter. Basically, though, if you're comfortable with the idea that when you're talking about a velocity, it's always a straight line and it's telling you which way it's going, versus speed is just saying, well, I don't care which way it's going, I just want to know how fast it's going, you should be fine. So then the next question is, how can we change that? So if we're going at 60 miles per hour, what are the things that can change that to the north? What are the things that can change there? Well, first off, we've got that 60 miles per hour, right? So, and I guess a reason we care about this is if we're trying to predict the motion of objects, if we're trying to predict what something's going to do, just knowing that, like, hey, one person's running 30 miles per hour, and that's insane. One person's running 15 miles per hour, the other person's running 20 miles per hour. Who's going to win? You can't actually tell. There's two things that'll matter for that in particular. The first one is if that's going to stay the same the whole time. I guess one of them could be running backwards. That also could really matter. But the other one I had initially thought of was where they are, right? If the person running 15 miles per hour is immediately before the finish line and the other person's 10 miles away, it's not a contest. So there is more information that you need, and one of the big ones that you need in particular is going to be how the way you're moving is changing over time. So there are three things you can do to mess with that. The first one is going to, and second one are both going to be messing with the number part of it, the speed part of it. So you can speed up. That means that you'll be getting progressively faster, which again means you're traveling a greater distance every second. You can slow down, which means that you'll be traveling progressively less. And a lot of people say that the third one is stopping, but stopping is actually just a really extreme case of slowing down. You're slowing down so much that you do nothing. And the third one is that you can change that direction. Remember how I said 65 miles per hour north? If you bump that up to 70 miles per hour north, that's speeding up. If you bump that down to 60 miles per hour north, that's slowing down. But if suddenly you say it's 65 miles per hour to the northeast, that's also changed what you're doing in some way, right? And that change is a change in speed, which this is like slightly too high. That changes, a change in your velocity because it's changing the direction of it, and that's also a way to change how you're moving. So all of that, also the turning, all three are acceleration, or caused by acceleration or examples of acceleration. So if you say, you typically don't want to say, like, decelerates from 70 miles per hour to 60 miles per hour. No one's necessarily going to fault you on it, but one of the big problems with doing that is it makes you think that those two processes are different from each other. And they're not. So especially for this class, just think of acceleration not as speeding up, because that's only one of the three options. Think of it as anything that changes what you're doing. So definitionally, acceleration is the rate and direction in which you change how you're moving. Another way to say that is the amount by which you change your velocity, meters per second, each second. The units for that are going to be meters per second squared. The reason this is hopefully fairly intuitive is that it's meters per second each second. So if I say that my acceleration is 10 meters per second squared, what that means is every time you wait a second, however fast you used to be going, assuming you're not creating directional change, you'll be going either 10 meters per second faster or 10 meters per second slower every second, with some notable exceptions that get weird around like 0. So again, you got three options for this. The first one is when you speed up. Now, what acceleration does with that, like, let's say 10 meters per second squared, is it says, okay, well, let's say that this arrow is representing my velocity, and let's say that it's plus 5 meters per second. And I'm actually going to make it plus 15 so that I can demonstrate something. If my acceleration is minus 10 meters per second squared, what that's telling me is that every second I need to take 10 and subtract it from my current velocity. So at 0 seconds, it'll look like this. At 1 second, we'll have taken that 15 and taken away 10. So what we'll be left with is a velocity that looks like this, of plus 5 meters per second. After 2 seconds, what it'll look like is something where now we've wrapped around and started to go backwards, because we've taken away this comes up more later. Backwards is classified as being negative, and so one direction will be positive, one direction will be negative. You can actually pick which is which. In this case, I've picked to the right to be positive, to the left to be negative. So when I take that 5 and I try to take away 10 from it, it brings it into the negative. So now it's actually wound up turning around. And if I wait till the 3rd second, it'll be going negative 15 meters per second. And if I wait till the 4th second, it'll be going negative 20 meters per second. 25 meters per second. And so what's interesting about this to me, and what tends to be kind of tricky for people, is that if you're looking at what's happening, from 0 seconds to 1 second, it's actually slowing down. And this is because it's moving forward, but you're taking away from that forward. It's moving forward, but you're taking away from that forward by an amount of the acceleration every second, because you're saying add more negative, add more backwards to it. If you add backwards to forwards, it makes it smaller because they're fighting against each other and you slow down. But watch what happens after 2 seconds, because after 2 seconds, the velocity is negative. It's going backwards. But we keep adding backwards velocity to that. If you take that backwards and you add more backwards, it just becomes a bigger backwards. And so you're actually getting faster. This tends to throw people off. Negative 25 is bigger than 15 when you're talking about velocity, or at least it's faster than 15. We're normally not going to be talking about the absolute scale plus or minus unless we're talking about something called scalars, which isn't going to happen often. We're really caring about the size of the number. And so I don't know where else I was going with that, but yeah, just be really careful, because just because your acceleration is backwards doesn't actually mean you're slowing down. If you're moving forward and the acceleration is backwards, they'll be opposites from each other, so yes, you'll be slowing down. But if you're moving forward and the acceleration is also forward, you'll be speeding up. Similarly, if you're moving backwards and the acceleration is backwards, you'll speed up. If you're moving forward and the acceleration is forward, you'll speed up. If you're moving backwards and the acceleration is forward, you'll slow down. The way that you get something to turn, and this won't matter much until we get to the forces unit, is, and especially when we get to the circular motion unit, is by having your acceleration be perpendicular to the direction you're moving. So if you're moving forward, having your acceleration be partially pointed forward will make you go faster. Having it be pointed backwards will make you go slower. But having it be pointed to the right or left will make you turn in that direction. And if your acceleration is some combination of those, then you'll do some combination of those. So if it's like forward and to the right, then you'll speed up while turning to the right. If it's backwards and to the right, you'll slow down while turning to the right. And I keep forgetting that it's flipped on your end, so sorry about that. I also forget how to use the pen. So, a little weird when you can't talk back to me, but take a sec, think about these questions, and I'll sort of talk about them and go through answers. Pause now. Unpause now. It's a joke. If you actually pause, you couldn't. So, as far as what it means for position to be constant, because position is describing where you are, if your position is constant, that means that your velocity is 0, and it also means that your acceleration is 0, because you're not changing that you're not moving, and it means that you're not moving, you're in the same spot. If your velocity is constant, what that means is that you aren't changing how you're moving, but you are still moving. So that means your position will constantly be changing, but your acceleration has to be 0 because you can't be changing how you're moving, which is what acceleration does. If your acceleration is constant, it actually means that your position should be constantly changing over time, and your velocity will also be constantly changing over time, and pretty much nothing's going to be constant, except maybe the acceleration, because it's... So, real quick, the big difference between constant velocity and constant speed is just the difference between velocity and speed. Velocity includes direction, speed doesn't. So if you're going at a constant velocity, it means your acceleration is 0. You're not speeding up, you're not slowing down, you're not turning. But if you're going at a constant speed, it just means you're not speeding up or slowing down. It doesn't necessarily mean you're not accelerating. You could be going at a constant speed while turning, in which case you will still be accelerating. If an object is traveling at a constant 20 meters per second, in the first second it'll go 20 meters. In the second second, it'll also go 20 meters. But if it's traveling forward at 20 meters per second while accelerating forward at 5 meters per second as well, because those two match, it'll progressively go faster over time. And so in the first second, you'll add 5 to that, so it'll go from 20 to 25. After 3 seconds, you'll have added 15 to that, so it'll go from 20 to 35. And this is accidentally discovering one of the kinematic equations that we'll be spending a lot of time with later. And that's pretty much it. Next time, we'll dive more into sort of how these things have a little bit more practical application. as opposed to just sort of abstract concepts. But for now, that's it. Goodbye, YouTube.